Hello everyone, my name is Darla Saunders and on behalf of the Atlantic Salmon Conservation Foundation and the Canadian Rivers Institute, I'd like to welcome you to today's webinar. This series is made possible in part thanks to the contributions of the Government of Canada. For today's webinar, we're absolutely delighted to be hosting Professor Ken Whelan. Ken is the farthest afield webinar speaker that we've had to date. He's joining us today from Dublin, Ireland. He has a wealth of experience and has worked with such organizations as the Inland Fisheries Trust, the Central Fisheries Board, the Salmon Research Agency, and the Marine Institute. Professor Whelan served as president of NASCO from 2004 to 2008. As president, he helped coordinate and manage a recently completed major international study into the causes of marine mortality of Atlantic salmon. He has served as chairman of the International Atlantic Salmon Research Board and is currently chairman of the Scientific Council of the Loire Basin Salmon Restoration Program. In 2009, he was appointed as adjunct professor in the School of Biology and Environmental Science at University College Dublin and as research director of the Atlantic Salmon Trust. In 2009, he also established a fisheries and environmental consultancy. So after the presentation, we'll be opening the floor for a question and answer session. You'll have the option of asking questions directly using your microphone, or you can type them in and we'll read them aloud. So I will now turn the webinar over to our speaker, Professor Whelan.
Thank you very much indeed, Darla. And good morning or good afternoon, depending on what part of the earth you're listening to me from. We're going to talk a little bit today about the hidden importance of small coastal streams. You might be wondering why I became interested over the last decade or so in these tiny bodies of water. It's probably mostly down to the fact that over a period of 4 or 5 years, my friend Chris McCulley and I spent a lot of time fishing around the coast of Ireland, primarily for the lovely fish that we have here in Britain and Ireland called the sea trout. The sea trout is a brown trout with a silver coat, and we'll get on to that in a little while. But certainly, as we moved around these estuaries and coastal margins, we became absolutely fascinated with this fish. It may seem strange to be invited to speak about sea trout by a salmon conservation group, but in essence, the sea trout, we feel, is a really interesting analogue for what may have happened to all of the migratory fish that have subsequently appeared in our little streams and in our lochs and in our bigger rivers since the Ice Age. I think the story really stretches back, certainly in Britain and Ireland, to the last glacial maximum, which was about 22,000 years ago. And at that stage, certainly all animals and plants in Western Europe were in an increasingly hopeless struggle to try and survive. The exposed surfaces of the earth were gradually covered in an ice sheet, and there was no soil or running water. And the islands of Britain and Ireland were completely covered by ice, and all animal and plant life was extinguished. Now that certainly is something that we didn't know even a decade ago, and I'll come on to that in a little bit more detail at the next slide. But around 14,000 years ago, the climate began to turn far milder. And this allowed the first colonization of the land, and indeed we believe now perhaps the first tentative colonization of freshwater. But the important thing to remember is that all fish species had to come from the sea. What we now know as the sea, it may have been a very different type of sea, it may have been far more dilute, but certainly aquatic visitors came to us either from the sea itself or by means of eggs that may have been carried by birds or whatever into the rivers. But primarily, I think it was from the aquatic environment. And it was around the period of 14,000 years ago to 10,000 years ago that the migratory trout began to invade fresh water and to establish populations of migratory and resident fish in Ireland. And certainly, the first fish that we saw was the char. And we still have remnant populations of char in Ireland and in Britain, but these are confined to hill lochs and are isolated non-migratory stocks. Certainly when I was going to school, this is the sort of map that we were presented with in terms of the Ice Age and what the Ice Age meant to Ireland as a country. You'll see that constantly these maps show gaps small areas of Ireland that were free of the nasty ice as such. But certainly from the work of the Marine Institute and the work that's been done off our coast in recent years, we now know that that is not the case. These ice sheets were immense, and they covered all of Britain and Ireland and went way out towards the continental shelf. And indeed, in the sediments off our coast, we're finding remnants of these massive great ice sheets. This huge ice sheet, which we call BIS, or the British and Irish ice sheet, it was twice as large as previously thought. But importantly for us, it was drained by gigantic ice streams. And these were etched in places by ice shelves. And it was very, very similar to the West Antarctic ice sheet. This was a marine-based ice sheet off the coast, and it had a lattice structure. It may have looked very solid, but it was very susceptible to breakages due to sea level fluctuations. And as a result of that, you had collapses and you had all sorts of ice streams moving around and actually bringing them out about the demise of these great ice sheets. Each major retreat of the ice was accompanied by a re-entrenchment of ice on the landscape. It wasn't a simple melting. We now know that over thousands of years, the ice expanded and retracted and expanded and retracted. And it was a series of these retractions, and we can see evidence of that in the landscape. And certainly in the context of the western and the northern parts of Britain and Ireland, these were the areas where eventually the landscape as such became ice-free. But around the time of the last glacial maximum that I spoke about earlier, 20-odd thousand years ago, the sea trout weren't even close to us. They were neatly ensconced somewhere around the Mediterranean, we think. But the Mediterranean at that time bore an uncanny resemblance to the Baltic of today. So these fish were always seeking out the environment where they are happiest. And certainly that environment is the semi-saline conditions that you find in estuaries and bays. But given the extent of the ice fields over Ireland and Britain, there's no doubt that the trout were not present in the rivers and lakes in periods beyond 14,000 years ago. And assuming that fish breed on average every 3 years, and that we saw the bulk of the fish appearing about 12,000 years ago, this only represents about 4,000 generations, a mere blip in the time continuum that encompasses the evolutionary history of the brown trout. But they colonized our rivers and our lakes in a surprisingly short period of time. And constantly over the next half hour or so, I'll come back to this ability that these fish have to colonize. And they are, across the globe, one of the most successful invasive species. So the brown trout is one of the most adaptable creatures. I thought it might be interesting just to have a look at some of the shapes and colors that these fish can actually that they can actually acquire. It's very important as well to take the advice of a friend of mine, Ed Fahey, who wrote a wonderful book about 20 years ago on the sea trout. And in that, Ed advised us to forget about the coating. It doesn't matter whether a trout is silver or whether it's brown. They're basically fundamentally all the same species. And we're much better off to call them migratory trout rather than calling them sea trout or resident trout or whatever. Because certainly in Britain and Ireland, increasingly we're seeing linkages between the fish that migrate into saltwater and the fish that migrate in and out of our Great Lakes. They are one and the same species. They just happen to be doing it in freshwater rather than in saltwater. The other thing that we have seen down now the decades, we've seen this amazing ability of these fish to rediscover the salt and to rediscover salt water. Even stocks that were put in as fishing stocks on a put and take basis into urban rivers such as the River Dodder near me here in Dublin, these stocks have found their way back into the sea and had no problem adapting to the salt water. Some of these have come back at 9 and 10 pounds weight, whereas originally these strains would have come from Surrey in the south of England, and they would have been resident stocks, inverted commas, for decades, if not hundreds of years. But we have numerous examples of trout regaining their migratory habit. And again, I'll bring you on a little mini world tour at the end to try and show you where this has happened, not just in Britain and Ireland, but across the globe. But these fish come in all sorts of shapes and sizes. And as I say, the most important thing is not to be fooled by the different shapes, sizes, and particularly colors that you see. These are all fundamentally the same creature. So that's a little bit of background in terms of the migratory form and the resident form. But in terms of the small streams component, in recent years in Ireland and the UK, we've become really interested in the conservation and management of these tiny little streams. We have in place in Europe a very fine piece of international legislation called the Water Framework Directive. And over the last 15 years, and indeed this week is the week when it must be finally fully ratified, but over the past 15 years, all of the countries in Europe have signed up to this Water Framework Directive. And it's a magnificent piece of legislation, as I say. It's done a very fine job in helping us to clean up the water quality of our rivers and our lakes. The one problem is, and it's an understandable issue, that it doesn't reach into the very tiny streams. It is really looking at the larger streams and the rivers and assuming that by sampling these, you get a view of what's happening in the highlands in particular, or indeed in the case of urban streams further upstream. But what we know is that in reality, somewhere approaching 70 to 80% of all of our river systems, and indeed tributaries of our loch systems, are streams that are first and second order streams. We had a workshop on small streams some years ago, and we fought like cats and dogs for about a half an hour trying to argue about what constituted a small stream. I'm not sure it's possible to give a width and to say that's definitely a small stream, but what we're talking about, I think, in essence, are first and second order streams. But because these streams are so small, they are particularly vulnerable. And they're not just vulnerable to the general pressures that we're aware of, but they have very unique pressures on them, which again we look at in a little while. These little streams provide very important spawning habitats, but the problem is that physically they're very easily blocked by, for example, impassable culverts, which is a very common problem here in Europe. Farm crossings, indeed even minor land changes can result in a situation where some of these streams, the fish find them very difficult to get into them. They're also adversely affected by minor land management practices, and again we have to make our farmer friends much more aware of the importance of some of these very tiny streams, which to them may only function really as a source of water for their land, for their stock. And certainly in Europe, they are very poorly protected in the context of existing legislation. The other thing that's very useful to do is to separate out the small headwater streams and these little self-contained coastal streams. And it's the coastal streams that I'm particularly interested in and that I'm going to talk to you about today. And these little guys receive little, if any, attention from researchers. They're primarily of importance to brown trout, both in terms of inverted commas resident fish and migratory fish, but also in quite a number of locations they do hold small numbers of Atlantic salmon, primarily grilse. These would be small fish of maybe 2 to 6 pounds weight, but they can be important in the context of some of the catchments around our west and south coasts. There are very, very large numbers of these tiny coastal streams around Britain and Ireland, and often they hold an abundance of fry. And really, up to about 4 or 5 years ago, that was it. That was what we knew about these little streams. Now, just to give you some idea of what I'm talking about, this tiny little outlet here is actually a sea trout spawning stream. You can step over this, so it is surprising to think that it's actually adding fish to the bay that you see in front of you. If you turn around and look upstream, you see that it runs under a little bridge and up at the back of these houses. Very luckily, none of these houses have any effluent going into this little stream, and the water quality is excellent in it. It's no longer than about 10 kilometers, about 6 miles. There's probably only 2 miles of it that fish can spawn in. But each October-November time, large sea trout move upstream into that little stream, lay their eggs, and then move straight back down into the ocean. So these sort of little streams are everywhere around our coast. And up until very recently, we never thought about what these streams might indeed be contributing. I certainly was involved with colleagues carrying out surveys in the 1980s, looking at streams and looking at small streams like this. And more recently, a very large international program called the Celtic Sea Trout Project was again very busy looking around at these, and they found that they held very significant numbers of trout fry, and it was very rare to find one that didn't have fry, at least in the stream. They had no way of telling whether or not the fry were from resident fish or migratory fish, but since they discharged freely into the ocean, it's likely that many of the adult fish were actually returning from the actual ocean itself. Another very important feature of these tiny little streams is that they have a tendency to be flushed downstream or forced out by drought. Now, when we look at the natural biology of these sea-run brown trout, these sea trout, in the larger loch systems, what we find is that they're most successful in tiny streams. They are fish of tiny streams. And the streams they tend to regard as really spawning channels. So the bulk of the fish that recruit back down into the freshwater lochs aren't from the larger rivers, which are largely dominated by the salmon. They're from these tiny streams. And it's feeding fry and very early stage fry having fed for a week or two or a month or two that move back down into the lochs. This is exactly what we see in the context of these little coastal streams. And it's the lower freshwater and the estuarine pools that hold the highest numbers of these very small juvenile fish. Very often these little streams have a steep gradient, and the migration upstream is often blocked at varying distances from the ocean by steep rock barriers. And the little stream that I showed you in Bangor in County Down a little earlier, that's exactly what's in place above those houses. There's a rock barrier and there's nothing above that particular location in terms of migratory fish. There may very well be small resident trout, which biologically may be important, but that's for another day. We certainly have anecdotal reports and observational reports that these streams hold significantly large adult fish returning from the ocean at spawning time. The females often appear heavily laden with eggs, hang around the mouth of the streams for a short while, and then run up, lay the eggs, and then run back down again into salt water. Some of these fish can be 1 to 2 kilos, they can be 2 to 4 pounds in weight, and certainly they can spawn and have been seen to spawn on a single flood event. So the chances of a casual observer actually seeing these fish in these streams is probably very small. When we were doing the work for Nomads, our book on sea trout, we noticed that appreciable numbers of sea trout, particularly what we call finnock, and finnock are fish that have gone into the sea in May as little smolts of maybe about 6 to 8 inches long. They have a tendency at times to return back in fresh water as immature fish in the autumn. But we found that these early finnock that go out, a lot of them do actually stay in the ocean. But they don't stay in the full ocean. They have a tendency to come in to large sandy bays. And again, what are they looking for? They're looking for these semi-saline conditions. They're looking for the conditions that epitomize the habitat, the marine stroke freshwater habitat of the sea trout. There's a very large estuary in Northern Ireland called the River Bann Estuary, and we were amazed at the numbers of fish midwinter we found in this big estuary. The interesting thing is that there is no well-known, inverted commas, sea trout fisheries in this area at all. What's happening is that it's gathering in fish from a lot of very small streams in the area. Certainly the fish that we encountered in those bays, we feel that they are coming, as I say, from these small streams, but they may be providing an additional and very important contribution to the marine recruitment of sea trout. In Ireland and in Britain, we have increasing interest in fly fishing in the marine environment. People fish a lot for our European bass now over the winter periods. And in doing that, they're encountering more and more of these sea trout. But the numbers of sea trout they're encountering belie the numbers that we find in terms of the traditional freshwater fisheries. So they have to be coming from somewhere. And our argument is that these small coastal streams have a huge importance in terms of providing fish into the marine environment, and may be of a critical nature in terms of the provision of recreational fisheries. So what about other countries and other areas? Is there anything else similar to this around in terms of starting with sea trout and then maybe looking a bit towards some of the Pacific species? In Norway, we know that young sea trout can abandon their nursery streams and move to saltwater very small trout streams, and I think you'll agree what I showed you earlier was an extremely small trout stream. They extend their feeding habitat by actually utilizing the mouths of the streams and utilizing that area, that semi-saline area. So they don't realize that they should stay in fresh water. They seem to be well able to take to the semi-saline conditions. So they extend out the feeding habitat. And the lower the water level, the more inclined they are to actually do this. So when parr leave fresh water during their first year of life, they appear to need this brackish water feeding area. They don't seem to be capable of actually dealing with the full salt. So they're going to feed locally and feed around their natal streams. I can remember well in the early 1980s, the first time I came across silver parr in a little stream in the northwest of Ireland, and going back to my boss at the time and trying to explain to him that I felt that these fish were, sea trout. And he said, oh, nonsense. He said that they wouldn't go out at that stage. They'd have to be smolts. But that doesn't seem to be the case. These fish seem to be much more adaptable than we think. And certainly in some of the Baltic islands, the fish can move to sea soon after emergence. And this mimics exactly what I was saying earlier, where these fish in the more traditional fisheries, when they're spawning in freshwater, it's after emergence and it's as early feeding fry that they move back downstream. This tendency to move is there all the time. And this certainly is a life history strategy. Until recently, we would have thought of as just confined to Pacific salmon species and their relatives indeed. But some fish may even spawn in brackish water, some of these sea trout. And again, this was unthought of and unheard of. And the idea that you'd actually get spawning in semi-saline conditions at maybe a salinity of up to 4 parts per thousand, that certainly was something that people would not have thought about. But it's very nice to see that we have a lot of analogies in terms of the Pacific species that those who have joined us from North America will be all too familiar with. So in terms of pink salmon, the fry move out to sea immediately after emergence, again mimicking what we saw earlier, and some populations actually spawn within the intertidal zone. The chums then show the next least reliance on fresh water for rearing, and they spend maybe a few days or a few weeks in the streams and feed then the estuaries before migrating back out to sea. So what we're seeing is the Pacific West Coast salmonids making the very best use of the habitat they have available. Why should not our sea trout have done exactly the same in the past? So what we're seeing is, in the context of these small streams, the remnant behavior of the actual original of the species as such. In terms of what I described earlier, these adult sea trout moving back in quickly, laden with eggs, that is exactly what happens in terms of the pink and the chum salmon. I should have mentioned at the beginning that in the context of our sea trout, females predominate. So you very often can have 70–80% of the fish that go to sea may be the females. And that makes a lot of sense. I mean, why would you waste time in terms of trying to evolve a situation where the males would also go to sea? There was little to be gained by feeding up a male at sea, whereas the female, feeding her up at sea and getting more eggs, that was going to give you an advantage in terms of evolving and moving forward. In terms of coho then, they often enter freshwater in a less advanced stage of maturity, and they can spend a month or more before they spawn. And obviously the steelhead then are analogous in so many ways to our Atlantic salmon. They go on these big, long freshwater migratory journeys. They come in as immature fish largely and mature then when they're in freshwater. But probably it's the biology of the cutthroat trout along the west coast of Canada that really mimics what we're seeing in terms of our sea trout. So constantly you can see the analogy here between what you're seeing in the Pacific and what you're seeing in the Atlantic. And the other interesting thing is keep remembering that the Pacific salmon, the original Pacific salmon, were originated from the original Atlantic salmon. So really it is no surprise that we have this common evolutionary pattern. We're also seeing some very clever adaptations. the adult sea trout have adapted to return later in the season, and at times they can reach this appreciable size before they spawn. And biologically, this makes an awful lot of sense. I did some work many years ago with a colleague on the River Erith in northwest Ireland, and we were able to the eggs, something like 80% of the eggs laid by sea trout were laid down by 1 and 2 sea winter maiden sea trout. These were sea trout that had spent full years or full 2-year period at sea. So the bulk of the fish that were laying eggs was concentrated in just a very small number of year classes. And when you think about it in terms of the small streams, this adaptation is ideally suited to the physical nature of the transitory coastal streams, because like the cutthroats, it's likely that few fish from these streams will succeed in spawning more than once or at most twice. Whereas in some of our larger sea trout fisheries, sea trout can spawn up to 8 times. So again, you can see that that's been an evolution towards that feature rather than something that perhaps was inherent in them when they first moved in from the salt water. So let's think a little bit then in terms of the impacts. How exposed are these little fish, particularly in relation to climate change? It certainly wouldn't be appropriate to let today go by without talking about climate change, because there's so many people talking about it in Paris as we hold this webinar. But we're very lucky in Ireland in that we have a unique monitoring system in the west of Ireland called the Burrishoole system. And for 50 years we have daily data. We have records from a little Met station that's based in Burrishoole. We have fish trap data. We have data in relation to water temperatures. And a very, very large array of this is based on daily information. So we decided that we'd look at this and we'd see what was it telling us in terms of future trends. What did we think might happen between now and the turn of the century? What we did then was to take some of the global climate models and to downscale them. And we downscaled the models, and first of all we hindcast to see if we'd come up with data that was similar to the data that had been collected. And it gave us great confidence that what we were looking at were real results. And we then did some forecasting in terms of seeing what these models might indicate could be the situation in the years to come. And remember, these results that I'm going to speak a little bit about now, they're only verifiable at the moment in the context of one small stream on the west coast of Ireland. But I think they're very interesting in terms of the overall trends that we're seeing. The most important thing we saw was an increase in terms of winter, spring, summer and autumn temperatures, so that the average temperature was going to increase, and by the 2080s we certainly were going to see warmer streams. There was also very clearly a trend towards extreme low flows, and this was particularly notable during the summer and spring seasons. So again, these small streams may be disproportionately challenged as a result of the drop in terms of water levels. There's going to be an increase in the average number of consecutive days for which flows are equal to or below the minimum acceptable threshold. In essence, I think you could summarize this by saying, look, fish don't do well if there's no water. You know, it's as simple as that. If we're going to lose water, we're going to lose fish. So we really need to be aware of this. And certainly any management actions that in any way compromise these small streams may result in the loss of these subpopulations out of these small streams, if that in fact is what we have in them. But in direct contrast, not alone do we have a situation arising in terms of extreme low flows, but we're going to see a situation where we're going to witness extreme increases in terms of average flows and in terms of large flood events. In Burrishoole, we've already witnessed that some years ago. We had an extraordinary rain event that fell on top of all of our instruments in Burrishoole. We were really lucky to be able to actually record this, but the extremes that we recorded at that time were quite extraordinary, and the damage that was done in the context of the small streams, still we are seeing a very partial recovery in terms of some of the smaller streams. We lost 3 bridges and we had 4 landslides in a 2.5-hour rain event. So if we have that repeated over the country and over Britain, we'll see a very changed landscape in terms of these very small streams. But the question really is a question, as I said a couple of times now, of adaptation, and how well adapted are sea trout from these small streams to deal with these sort of adverse events. Certainly the sea trout stock structures would appear to be much more robust and resilient than that of salmon. They hedge their bets really well. They tend to go to sea at a larger size. Very often they go to sea as older fish, somewhere between 1 to 4, tending towards the 3s and 4s. Also the adult returns, there's a huge mixture, a complicated mixture of different returns and different choices. In essence, really, what we're saying is no matter what happens, these fish actually have options available to them. There are always a few bankers at sea, and these bankers can come in and recolonize. That's fine as far as it goes, but if you're in a situation where the river is minus water or has a very low flow at a particular time, even that may not help you. So these fish then that originate from these very tiny streams, certainly they're exhibiting all sorts of adaptations in relation to smolting and in relation to sexual maturity. But let me bring you on a little world tour now, and let me show you what these creatures do when you take them completely and totally out of their own environment. This is New Zealand, and until relatively recently, New Zealand obviously was very, very famous for its migratory fish, for its resident fish, but not much attention was given to its migratory fish. But when you look at the actual amount of productivity, particularly in the rivers that are on the right, you'd wonder why would any fish leave those rivers, particularly when the fish that were stocked in the 1880s to the 1900s, they were all from resident sources of fish. But increasingly, what we're finding is that there are very substantial numbers of wonderful sea trout present along the coastline in New Zealand. And these sea-run brown trout, big silvery fish that they are, a lot of them appear to be from very small streams. And certainly in the southeast of the South Island, in a place called the Catlins, it's just extraordinary to see the number of these fish that appear on each of the tides. Little fished by anglers and little known about. But these are fish that have done the complete reversal. They have come from a situation where their ancestors were in the sea to a situation where their more recent ancestors had adapted to fresh water, and they now have readapted to salt water again, an entirely plastic fish. The other location then where we're seeing increased numbers of migratory salmonids, both in terms of Pacifics and Atlantics, is in Chile. And Chile, as you probably know, is a massively long country. It's very thin, but it has a very, very long coastline. And it's divided up into these very nice regions. And there's two main regions of interest to us. There's the lakes region and there's the rivers region. And originally there was 44 native species of fish in Chile, but these were mainly galaxids and perch-like species. None of them grew to any appreciable size. But certainly it was very obvious that these rivers held a great deal of natural productivity. And so from the 1840s onwards in Chile, there was an attempt to actually utilize these rivers, not for sport fishing, mind you, but for aquaculture. In Chile, there's always been this interest in aquaculture, whereas in New Zealand, the rivers were actually stocked with a view to actually providing sport fishing. The numbers and the variety of fish that were stocked in Chile and that were stocked in some of the other small islands that I'll mention in a moment is quite extraordinary. But certainly from the early 1900s, as you can see, very, very high numbers of Atlantic salmon, brown trout, rainbow trout, brook trout, all sorts of different Pacific salmon as well. They've been tried and tested in Chile, they've been stocked in, they've been ranched, they've been reared in aquaculture facilities. And what you have in Chile at the moment is this massive abundance of migratory fish, both Pacific and Atlantic. And I've worked over there a little bit, and it's very difficult to get your head around exactly what's happening. But what we do know is that in the context of the brown trout, that the brown trout in Chile were important in the context of Chile itself, but they were also important as a source of eggs for some of the other countries. But in the context of the fish themselves, there was one group that I came across that particularly interested me. And we often hear the term, particularly in North American magazines, people talk about German browns, the quintessential resident fish that lives in the middle of Europe and hasn't seen the sea for millennia. Well, in reality in Chile, these German browns, nobody had told them that. And in the Mojine River, they have been running to sea now for decades, coming back in, turning colour very quickly back into their brown coloration. They have the most extraordinary blunt snub nose I've ever seen. They're very, very specific, their morphology, but still they're willing to put on the silver coat when they go to sea and pretend they're sea trout. So again, this shows the adaptability of these extraordinary fish, and they are making really good use of the wonderful feeding that's offshore in Chile at the moment. So that just gives you an idea of the area I'm speaking about, this area here. But what you have now is you have a spread of migratory fish right around the tip of South America and right up into Argentina. So we now have even Chinook that are feeding and going to sea in the Atlantic area of Argentina. So as I say, Southern South America at the moment is a real melting pot in terms of what's happening. That'll just give you an idea of the sort of landscape in Chile. And interestingly, there is also a very large abundance of brook trout, but the brook trout tend to cross constantly with the browns. So you have a very high proportion. I've never seen so many natural tiger trout as you find in Chile. But certainly these Chinook salmon are testament to just how rich the feeding is off the coast. The other island then we might visit for a minute is the Falkland Islands. The Falkland Islands, you know, lie just off this coast of Argentina. Again, a British protectorate, and the trout here were established thanks to the assistance of Chile. So the importation of the eggs to Chile actually resulted then in this great story in relation to the Falklands. It wasn't until the 1940s that people thought about putting trout onto the Falkland Islands. It's a very barren place, and there's not great productivity in the waters themselves. So the brown trout were brought over to the Falklands, and of course very quickly they realized that at sea there was great feeding to be had. They did extraordinarily well at sea, and not alone are there very large numbers of sea trout in the Falklands, but as you can see from the photograph, they also attain a very large maximum size. The fish, as was the case in Chile, transported in all sorts of strange ways, using milk churns, panniers on the back of horseback, water butts, even the local inter-island mail steamer, the RMS Fitzroy, was used to try and spread these fish around. So if you go across the oceans from the Falklands to this little group of islands here, and let me admit that up to 5 or 6 years ago, I had no idea that these little islands existed. I got a phone call one afternoon from guys that were working on these islands who were looking to apply for a research grant from the Atlantic Salmon Trust that I work for. And I said, "You're working where?" And they said, "We're working on the Kerguelen Islands in the Indian Ocean." And I said, "You're in the Indian Ocean and you want a grant to do some research on sea trout?" So the story unfolded then, because the Kerguelen Islands were first discovered in the 1700s, but it wasn't until the 1950s that you had people actually living on the Kerguelen Islands. So they are a French protectorate, but they're also very tightly controlled, and they're retained at this stage just for research. So you can't spend your holidays on the Kerguelen Islands. Not that you might want to spend your holidays on the Kerguelen Islands, but if that thought crossed your mind, forget about it. You'd have to go through all sorts of licensing from the French authorities. But interestingly, it is completely isolated. I mean, it's 3,500 kilometers away from Madagascar, so it's seriously isolated. The rivers and streams on the Kerguelen Islands were originally devoid of fish, but then between 51 and 91, they imported literally millions and millions of fish. Everything was thrown at the poor Kerguelen Islands. So they introduced Atlantic salmon, brown trout, Chinook, coho, lake trout, brook trout, Arctic char. And some of these have done very well. The three that haven't done well are the rainbows, the Chinook and the coho, but the others have done well. But the one that has stood out, the fish that is most adaptable, the fish that is now colonizing all of the various little islands and little trickles of water that are available around the Kerguelen Islands, are the brown trout. And again, these came from putative resident stocks. but very quickly they found that the extraordinarily rich seas around the Kerguelen Islands were to their liking, and they have now attained very substantial sizes. These are average size sea trout from the Kerguelen Islands, and it does show just again how adaptable these fish are, following exactly the same pattern. And for me, what these fish are doing home, they're going back to originally where they came from as such. So just a few parting thoughts, and then hopefully we can have a chat and a discussion. It's clear that small coastal streams are increasingly at risk from all sorts of anthropogenic impacts. And we really do need to try and quantify in our own areas the importance of these small streams, whether it's small streams high in the mountains, small streams in urban areas, or these lovely little coastal streams I've spoken about this morning. Certainly, we have to try and take more care of them. More research is obviously required to try and assess and quantify the importance of such streams in a biological context. Through the Atlantic Salmon Trust, we have funded some research over the last 2 years, and genetically we're finding in the south of England that a lot of the very tiny streams we're looking at seem to have very different populations of fish, just looking at the actual initial profiles of them from the genetic results. We had thought that perhaps these streams were basically taking, if you like, an oversupply of adults, or adults that weren't really top-class homers from some of the native rivers. That doesn't seem to be the case. These seem to be little entities on their own. How fascinating that is. And it's also important to remember that these are very interesting remnants. These may very well be remnants that are unscathed from the ancestors of the fish that we now are so interested in. They may have all sorts of lessons to teach us in relation to examining the last vestiges of the post-glacial fauna and flora that may be in these tiny streams. So certainly I would encourage you in your own area of research or your own area of work, don't ever step across those little streams again. Always step across and then look upstream, because you never know what treasures they might hold.
Thank you very much. That was a very interesting presentation. So as I mentioned earlier, we'll now open up the floor to a question and answer session. You have 2 options for asking a question. You can use your webinar control panel, which is the little gray box that you should be seeing in the upper right-hand corner of your screen. If the box is minimized, just hit the orange arrow and that will enlarge it. So you have 2 options. You can use the audio of your computer to ask a question by figuratively raising your hand, which is the yellow hand icon with a green arrow, and we can unmute you and you can ask your question directly, or you can type your question into the control panel and we can now read it aloud for you. And I see that we've got one question already. Okay, let me just open it up here. So the question is, good afternoon, Ken. This is a question from a former NASCO friend of yours, Peter Cronin. As always, great presentation. On this side of the pond that separates Ireland from New Brunswick, the primary conservation focus is generally on larger freshwater lakes and rivers. From your experience, how were you successful in gaining public and government interests and support in the conservation of first and second order streams? With limited financial and people resources, what are the trade-offs that should be considered if a shift of resources is required to increase the protection of smaller coastal streams?
Well, thank you very much indeed, Peter. And as usual, a very important question. And in reality, that's the reason why I'm with you this morning, is because of the fact that I got in contact with Stephen Chase to give me a hand with an initiative that we put in place about a year ago, where we decided that the only way to deal with the plethora of tiny streams that we have was to include the general public. There was absolutely no way that the state authorities, either in Canada or Europe, could possibly reach out to these very small streams. So what we've put together then is basically a layperson's training program. But the program is designed to actually collect data, not just to collect observations. And we have structured it so that the information that is collected then is stored by either a fisheries trust, which we have an increasing number of here in Ireland and in the UK, or indeed by a fisheries authority. The information is then made available to the authorities that are interested in farming or water quality or whatever, but it is quality controlled and it is data. And in order to be able to participate, the members of the general public program have to undergo a 3-day course, and the 3-day course will be certified by the Institute of Fisheries Management in the UK. So that means that people will actually have a qualification to tuck into their back pocket, as well as actually having the training. And again, we're only starting on this road. We have the material now gathered. It's with the printer at the moment, and we're going to carry out our first pilot courses early in the new year. But unless we take that approach, I think we'd largely be pushing a very, very difficult boulder uphill in terms of trying to get resources to deal with the plethora of small streams that we talked about a little earlier.
Thank you. So our next question comes from Michel Chouinard, and I'm going to unmute his microphone. Hello, Michel. Michel, can you ask your question? There seems to be a bit of a problem perhaps with his microphone. So I would ask that you type in your question and I can read it aloud for you. Okay, the next question we have comes from Joshua Roy. He asked, do you have a curricula available and training coastal stream monitor for training coastal stream monitors and suggestions for a volunteer coordinator?
Well, as I say, the program that we have developed at this stage isn't specific to coastal streams. It's specific just to small streams. We're only at the very beginning. But what we would be delighted to do is to share our experiences as we get some practical feedback in terms of how well it works and what's required. And it would be really, really interesting if we could develop as an adjunct onto our generic program one that dealt specifically with small coastal streams. And certainly we'd hope to do that in the future. But we already have, as I say, a developing partnership with the Salmon Foundation. We also have very close links with the Atlantic Salmon Federation. So through those two links, I think we can actually build a partnership and try and raise awareness of what we need to do in relation to these small coastal streams.
Thank you. So Michel has typed in his comment and he says, great presentation. The next question or comment comes from Rick Simpson. Rick says, brilliant. I'm booking my next fly fishing trip to the Kerguelen Islands. He says, I thought Mongolian trout and Siberian salmon were fascinating, challenging, and tempting. This presentation opened my mind to other possibilities. Love the work you are doing. When this presentation is available online, I'll let my colleagues at Trout Unlimited and other groups hear your words. Thank you.
Well, that's great. Can I just say, Darla, that I think he'll be the second person to get to the Kerguelen Islands. I'm determined that my rod and me will be the first.
Excellent. You've already got it scheduled. Terrific. All right. So that does seem to be the last of the questions. So again, a huge, oh, here we've got one more coming in. Art Niven says, Ken, lovely presentation. Is the Small Streams Training Manual publicly available or will it be limited to course attendees? Volunteer monitoring is essential to collecting information from these small streams.
Thanks very much, Art. Our hope is that we're going to try and manage its availability because we want people to understand that we're going to try at least to collect data rather than just observations. In that we've had a lot of feedback from the various authorities who have said, yeah, it was great in the past, we'd all these programs geared towards lay people, but what we got back was lots of tantalizing information but very little data. So as I say, our hope is that we will roll it out through official bodies and through registered private sector bodies, because we really want to be in a position so that we do know there's quality control in place, we do know that there are data being collected, and we do know that these data are publicly available. So there is that constraint on it. But in terms of the various groups, such as I know ART works with the Lochs Agency, there's Inland Fisheries in Ireland, there's the various groups, DFO and so on in Canada, we would be delighted to roll out the programme to them, provided that we can reach an agreement with them in terms of how the programme is managed. And that's why we need to do some pilot programs now early in the new year to make sure that we're on the right track and to get feedback from people to see if they're happy with the sort of formats that we have actually come up with. We're more than happy to actually revise this and to strengthen it depending on the feedback that we get.
Excellent, thank you. And Art replies, great stuff. So we've got Michel Chouinard has put in his question. He says, my question is, what could be done in regard of the increasing levels of coastal waters with climate change and the increase in salt water in the lower parts of rivers?
Well, I mean, there's probably not a huge amount we can actually do, but what we do need is to know. And I think it's the awareness thing that I'm most concerned about. Particularly in the context of that tiny little delicate stream that I showed you. It would be so easy with a mechanical digger to ruin that stream in a matter of a few hours. Equally, in the context of our coastal margins, I'm not sure what it's like in North America, but here in Europe, it's only in the last decade that we've begun to take seriously what was happening in our estuaries and in our bays. There was actually a very substantial amount of work done at sea and in freshwater. But these areas that are the intermediate areas between the two are very difficult areas to work in. And again, we probably need a lot more volunteer work and a lot more structured volunteer work to be able to point the way in terms of what is happening in these areas and the potential impact it could have in terms of these very delicate stocks, such as our sea trout and the equivalent sea-run brookies and so on in North America. I think it's an area where the lay groups and the volunteer groups could play a very important role.
Thank you. The next comment that we have is from Catherine McGlynn. She says, thank you, Ken. Really enjoyed the information from Nelson, Canada. Looking forward to hearing from the citizen science monitoring training and successes. So I think that is the last of our question. So a huge thank you to Ken and to everyone who participated. The next presentation in our series will be on December 9th. André Saint-Hilaire of INRS in Quebec will be speaking about water temperature modeling tools. The presentation will be in French, but the question and answer session will be bilingual. The next English presentation in this series will be on January 20th. Andy Sharp of East Coast Aquatics will be giving an introduction to water quality monitoring and data analysis for community-based watershed groups. Registration and a listing of webinars is available on the Atlantic Salmon Conservation Foundation and the Canadian Rivers Institute websites. So thank you everyone for participating, and again a huge thank you to Professor Whelan for having today's presentation. We hope you'll all be joining us again very soon.